Good day, everyone, and thank you for joining us today for our webinar on digital engineering. My name is Annie Lee, and I am the marketing executive for A-Site, and I'm tuning in from New York City. Today, we are pleased to bring you a presentation on the new era of digital engineering and how it can change our future in the AEC industry. Understanding these transformational benefits of digital engineering, it allows us to challenge the traditional way of delivery, and it can save us time and costs. Digital engineering with tools such as building information modeling, also known as BIM, it's about more than just creating models. It is about unlocking the knowledge and insight in real time, and this can create the platform for true collaboration. By reviewing the way that we deliver projects and implementing more advanced digital strategies alongside new ways of thinking, we can unlock the most efficient methods of project execution. So ultimately, if we can deliver projects in the digital world, then we should be greatly more educated to deliver the same project in the real world. So with me here today to share with us this presentation in detail, we have A-Site's Rob Clifton, the Digital Engineering Manager, tuning in from London. We will be handling questions and answers at the end of the presentation, so feel free to type any questions that you have into the questions tab on the right-hand side of your screen while Rob is speaking. That way we can get to everyone's questions during the Q&A session. So without further ado, I will hand you over to Rob Clifton for the presentation.
Right, good afternoon. Well, good morning and afternoon, I suppose I should say. So my name's Rob Clifton. I'm going to go through this presentation that I've delivered. I've delivered it kind of in a conference in America, and also kind of in a few or parts of it in webinars I've done in the UK. And with certain clients and conferences in the UK as well. So yeah, just a little bit of background to what we're going to be covering. So it's just about digital engineering. What does it actually mean, and how does it relate to what BIM is? Some challenges to implementing digital engineering concepts and softwares. Improvements any organisations can make. So looking across the industry. I'm going to go through a few concepts relating to the standards and of course the CD, and then look at some disruptions as well. So moving from from that 2D perspective really forwards towards kind of level 3. Just a bit of background to me. I'm a civil engineer by trade, but I've been in construction technology for 3.5 years, worked with all these companies here among others, focusing on kind of implementations of systems, but primarily on digital engineering as well. So we'll start off with a keyword that everyone seems to know, and to some extent have an understanding of what it may represent. However, I come across ever more cases of it being referred to as these different elements. So building information modeling, building information management, better information management. It's about trying to portray a little bit more what BIM is related to. Now, the reason we have the term digital engineering is to try and encompass everything that maybe BIM is being applied to and being used for. So digital engineering, what does that mean? The best way I can kind of explain it is to relate it to the built environment. So let's think about built environment and a project. You begin with groundworks. You start with the groundworks and you build up from there. So you have materials that's required to build your project. You begin with foundations. You require suitable foundations equivalent to the building you want to build. You expand that up. You have a structural core. You build everything around that structural core. It's the centerpiece of the building, or the core structure of the building. You then obviously add some more advanced elements to give the building some shape, the architectural features, and obviously anything kind of from an interior perspective. You add the external walls to expand that up, internal walls, and you end up with a completed project at the finish there. Now, the same principle in terms of how you go through a built environment can be applied to the digital environment. And this is what digital engineering represents. So in digital engineering, we begin with standards primarily. It doesn't have to be standards, but it needs to be a principled way of working. So these are 2 standards here. I'm going to come back to these later on. You require task teams or disciplines. You need consultants and contractors. We need people. essentially, to be able to construct the digital environment. We need a plan of how we're actually going to execute what we are looking to do. And the execution of that should be tied to this delivery plan. So it shouldn't just be about execution, it should also be about delivery. We then need this key element, the common data environment. It's a really key aspect of everything relating to digital, because it's the centerpiece that everything kind of pushes and pulls from. You can really think of it as the focal point of everything around it. We obviously have model information. Now, I'm not going to spend this presentation going into the strengths of Revit or the comparison between Revit and Bentley or whatever it might be, but obviously the digital environment has key ties to having model information, but it's more than that, and that's the key point I'm portraying today. Then obviously we have secondary model information, so the more advanced elements, what can we do with that secondary model information? And then finally, and progressively, we're seeing this more so, asset models. Digital twins is the common phrase I'm coming across with a few clients at current. So we have those two. We have the built environment, we have the digital environment, but the actual way you kind of build them up, you can think of them being kind of related, if you like. So you require a delivery plan as the structural core to information. You have to start with an execution plan as part of the foundations, and the common data environment is essentially what the primary elements of the digital environment represent. If you consider that engineering is required to deliver the built environment, then digital engineering is required to deliver the digital environment, and that's everything that encompasses. So going through some of those elements, let's kind of work through some of those aspects and have a look at those. So we're going to start off with looking at the challenges to implementing digital engineering and making it a mainstream kind of concept. We're going to move through to the improvements that can be made, and then we're going to finish with some, a little bit more advanced, a little bit chaotic kind of disruptive thoughts related to digital engineering and the industry as a whole. So let's start off with the challenges. The most common phrase I hear, but to be fair, I'm hearing it probably less now than I had done previously, maybe kind of 2 or 3 years ago. There does seem to be a change, but it's a common phrase. We've been doing it like this for 20 years. Why should we change the way we're doing things? And this is the perfect diagram and report, I should say, to emphasize this. So this is taken out the McKinsey report, which looked at the productivity. We're focused on multiple elements, but productivity specifically. And what we're seeing here is the growth in productivity per person in different industries. So beginning with that initial line, which is the total economy. We then kind of know, certainly most within the AEC industry will know, that manufacturing really has improved its productivity per person quite extensively over the last 20 years. What's quite concerning is that construction lags, far behind there, 2.6% in comparison to manufacturing, a growth rate of only 1% improvement in productivity per person over 20 years. And you think of the technological advancements and the new knowledge and the data that we have over 20 years, and we're only doing things 1% better. Even more incredibly, actually, the US, which I will pick on, the productivity per person in the AEC industry has dropped over 20 years, which is quite incredible, really. So why is that the case? So the first thing I want to say about digital engineering and BIM to some extent, it's very hard to quantify it. We still don't really have very clear-cut numbers of saying, if you do digital engineering, you are going to save X% on your bottom line. Whereas generally in the AEC industry, if you think about design, we can see if things go badly. These are examples of winners of the Carbuncle Award, an award we have in the UK for bad, or the architectural, I say bad design, but architectural unpleasing building, shall we say. It's very clear why they're awarded that, whereas it's not clear if digital engineering was done well or badly on those projects. So as I say, a means to quantify digital engineering and the value it has is going to be quite key going forwards. The other challenge I come up against is it's somebody else's problem. It's somebody else that needs to make the investments. It doesn't impact me, or it's up to somebody else to make this call. Well, this is me just breaking this out from client tier 1 and tier 2. Clients, the cost overruns that are experienced by clients are most often related to change requests, and better managing of those change requests through digital engineering would result in a reduction in cost related to those. We've got, from a tier 1 perspective, contractors on site, the majority of cost is related to labor. Now, if we can improve the efficiency of doing things, if we can up that productivity, then the cost of project is going to go down, and our margins either go up or we are more competitive on a greater number of projects. And then we have the tier 2, the specialists to some extent. Around 80% of those specialists deal in complex environments. You think of your M&E guys coming in late onto a project and looking to put in complex fire runs or fire systems, ventilation shafts, and that's where you end up with clashes and cost and overruns. So it affects everybody. So everybody is responsible here for taking it on themselves to make a change in what they're doing. And this is evidence of what the change would make. Again, this is coming from a McKinsey report, but really is quite key. If we caught up in terms of productivity with the economy across the industry over the last 20 years, we will be able to add 1.6 trillion to the GDP globally and deliver half of the infrastructure projects that are required. You think of HS2 in the UK, for example, being built at no cost simply because we increased the productivity. It's evidence of quite how important the impact of this is and how key it is that we make a change. So improvements, that's the main challenges we see. So how do we start improving what we are looking to achieve here? Well, the first thing is, again, I'm taking this report, but this has been reported in multiple different kind of white papers and similar, is the investment and the amount of digitalization within the construction industry. Now, firstly, the point here is there is a connection between digitalization or digitization and productivity. There is a connection between those. And construction lags behind every other major industry. So even agriculture and farming, they use a greater amount of technology and they have improved productivity growth. As a result, I think it would be fair to say, looking at this chart, there's clearly a relation between the two of that. So fundamentally, construction needs more technology. Now, it's obviously not just about pouring money into technology and hoping that that is going to solve and improve our productivity. We need to do it in the right way. But there is no doubt that the lack of technology and the underinvestment in that is causing us to be less productive. So we need to start improving that. And it's coming, but it's very slow. It's a very kind of transitional approach. So we need to make it move faster. And how do we do that? So this is a starting point. I've taken this, quite a lot of the stuff I present comes from outside the industry, because I think we need to look at ways of doing things a little bit differently. We don't need to keep focusing on the same what our competitors are doing, because it's just a transitional approach. So this is a theory taken from a guy called Sir Dave Brailsford, who certainly in the UK many will be familiar with, who was the head of British Cycling. And what his theory was from a sports perspective was to apply marginal gains, and if you made lots of small improvements in the way you were doing things, you would ultimately add up to a large improvement over your competition. And as I say, from a cycling perspective, that has obviously been thoroughly successful, with a particular focus on Team Sky and the number of Tour de France's they won as a result of this theory. So my same kind of message here is to apply the same principle of, we don't need to make a massive step into something that's completely unknown to us. We need to make lots of small changes into what we are doing. And if we break this down, if we actually take some of these elements here and we focus across the industry on where we can do this, improving the way we design, improving the technology we are using, executing more efficiently on site, all of a sudden you're talking about huge cost savings in the way we are doing. And some of the numbers that have been kind of thrown around from the government in terms of, certainly in the UK, as I say, I'm obviously based in the UK, based in London, so I will refer to that more so. But the numbers that are thrown around in terms of the targets moving forward by 2020, 2030, we are only going to hit those by making lots of changes in lots of areas. One big change is not going to achieve that. We need to make lots of changes in lots of areas, but we need to start doing it now because it takes time to impact. So the theory of marginal gains, I'm going to apply that to the construction industry. So basic principles, just to get everybody on the same page of kind of where we are. So construction age 1, I refer to it as CAD drawings, the basis, 2D drafting. Level 2 is what we talk about now. It's the main target for most of the industry globally, I would say, from experience in kind of different regions, from the Middle East to Australia and the US. Level 2 is generally the prime target, the idea of having model information and working those models through a federated kind of means. Then on the horizon, we have level 3. I get some queries coming in about this now. It's about looking at connected systems, integrating. You can see obviously just in that diagram there, the way systems are connected to give us a much more valuable data set than we would do by just having a pure model on its own, and maybe people pushing and pulling out of that as they require. So those are the kind of steps we need to move through. We need to focus on it one at a time. I would say we don't need to make these big changes. We need to make one at a time small changes that result in large improvements. Okay, so I've written a blog post on this, and I talk about this quite a lot, the BIM escalator. It's discussed, or it's kind of the theory was raised, and I was discussing this with a client, but it's the principle of how the industry is moving. And as I say, I think this applies globally. I don't think this is UK centric. I think globally, the industry is on a BIM escalator. We are moving from BIM level 0 or BIM level 1, that CAD kind of orientated environment, certainly towards level 2. So we can consider ourselves with improved standards, improved ways of working to be on this escalator. So we are moving up this escalator as an industry. So you, whichever level you are in your organization, or whichever part you have to play in a construction project, whether that be a client, whether you be a contractor, whether you be a consultant, you're on this escalator of a moving industry where I'm making movements going forwards. And in making those movements, you have a choice over what you want to do and how you want to approach this scenario. So one option that we see is people say, this change, this isn't good. We're not used to this. I'm fearful of this. So what I'm going to do is I'm going to go back and I'm going to start trying to work in the way I have always been working. The problem you've got with doing that is you are now working in an environment and with consultants and other parties in a fast moving area that are working towards level 2. So you now are no longer in control of where you are moving to as a business. And dare I say it, businesses that have that intention to work in the way they have always done will find themselves increasingly under pressure within the competitive market. The second option I've got is to stand still and say, okay, this industry is moving. I'm going to accept the fact we're moving, and I'm going to prepare myself thoroughly for that. And that's absolutely fine. You will move with the industry. You will kind of, as the standards improve, you will learn how to work with them. There'll be a wealth of information on the way of working towards level 2, but you will kind of succeed in controlling your own success. The third option you've got is to say, actually, this level 2 is an opportunity. This is a great opportunity for me to get ahead. And we're seeing companies, certainly that us at ASITE work with now, that are saying, we really want to change the way we're doing this. I mean, one I found particularly interesting is a string of projects I work with in the Far East, in Vietnam and Indonesia, that have all of a sudden said, actually, this is a great opportunity for us to show as a part of a global business that we can really make these steps forwards quicker than other parts of our organization. So the movement to level 2, you can use that as an opportunity yourself. So my question to anyone really is, which one of those 3, if you consider them being organizations, do you want to be? Okay, as I mentioned, I'm not too keen focusing on just about the model stuff. I'm more about the way we think about doing engineering and the way we apply that to our business, because I think that's how we're going to change things. Now, I come, as I said, from a construction industry, from working on site, and I spent an awful lot of my time, admittedly, looking backwards, asking these kind of questions when things happened. Who was responsible for that? Who's to blame for that? Why did that go wrong? And it's all about looking backwards. Estimates say we kind of spent 80% of our time perhaps looking backwards, looking at what's happened in the past, opposed to saying, actually, I'm going to change the way I'm thinking. I'm going to start looking forwards into the future. And when something does go wrong, I'm not going to look to blame somebody. I'm going to look to say, actually, I want to stop that happening again, to ensure that doesn't ever happen again. I want to improve the way we solve kind of situations that arise like that, and I can use experience and previous to apply that, which is why you still need to look partly backwards, but the focus should be forwards. And if we use these kind of principles, then we can make a big difference to the way we are delivering things. Again, I'm going to look outside the industry for this and for inspiration for this, to the aviation industry. The aviation industry has black box thinking. So it's about having within aircraft, when there's a problem with an aircraft, when there's a crash or an incident, they track everything that happened related to that incident or that problem. The same, you could think, will be applied to construction. And what they do with that information, with that data, is they apply it to the learning going forward. So they say, okay, this is what happened and went wrong. This is how we're going to improve it to stop it ever happening again. And it's why the aviation industry have now got such a great safety record that it's safer to get on an aeroplane than it is to get in your car and drive down the street. So you need to think about how we can look forwards and how we can apply that to the construction industry to improve the way we are doing things, rather than just looking at this blame game that we are quite notorious for as I say, having had experience of it working with a contractor. So those are some of these improvements, but let's return to the digital engineering, the actual aspects I referred to that really tie and fall under that digital engineering. So we're going to begin with 3 elements that kind of tie together at the start: the standards, task teams, and execution plan. So first off, digital engineering, you need to understand that there's going to be a bit more weight up front. You need to spend a bit more time at the front, which is what I'm going to be showing here. But you need to have confidence, and this is part of the key with it, and this is why people are fearful to make the step. You need to have confidence that the time you put in at the start is going to have value further down. It's going to save you time further down. You need to think of the overall time cost opposed to not just at the start. So you just need to be conscious of that. We've then got standards. There's 2 obviously key ones coming out of the UK, which is BS 792, PAS 792. These are being superseded by an ISO 19650. At the BIM Alliance meeting a couple of months ago, the intention for this ISO is by the end of this year, so it's coming very soon. And my understanding also is that it's very quickly going to become a European kind of standard for way of working across Europe. The US has also signed up to this. So the ISO 19650, based upon 1192, PAS and BS, is going to be the way to work going forward. So this is kind of really setting the scene for the next 10 years in terms of the standards we are going to be looking to use. I'm going to focus on PAS 1192 because to me, the BS is great, but it applies the kind of core elements, whereas PAS gives you a bit of more information around how the information flow works. So I'll be referring to that the most. And I start off, or for the most part, I'm going to refer to this diagram, which is your overall information flow for the project. I'm not going to do too much on the asset side. I may do that in another aspect. I'll touch on it, but I'm focusing on the project information model specifically and everything around that. So let's kick off with the need and the way we are asking for information. So we need to start off with those employer information requirements. We need to respond to those with a BEP. Again, I'm not going to go into these in too much detail. And then we focus on information delivery plans. So actually managing the way information is delivered on a project. So at the moment, the most common go-to is on the left, an Excel sheet describing everything I need. Each consultant has their own tab, and it's fine, but for the most part, they don't tie to the place you are delivering the information, the CDE. And what you end up with is an Excel sheet that is incredibly manual heavy. You've got a lot of people spending a lot of time trying to keep that up to date. And the result is it's always out of date. That's the biggest problem with it. So we need to look at smarter solutions to this. Again, I'm not going to do too much about ASITE, but we need to look at solutions such as ASITE has, where you can connect your information delivery plan to the CDE. So as soon as you define a new item to be delivered on your delivery plan, a placeholder appears in your CDE. So you're connected and you can deliver the fast rate on top of that. So we need to plan the information delivery better. We then need to actually mobilize every other aspect. Often we come in as a CDE provider quite late in the game. And quite late into the project, and sometimes that's too late to get the value of it out. So we need to be prepared and ready to push forwards. So now I'm going to focus on the CD itself. Now I'm conscious of time because there's a fair amount to get through here. So the CDE is talking about obviously the flow of information and the exchange of information in here. Now many will be familiar with the BS 1192 diagram on the right hand side, which maps the flow of information that defines the authorization and the exchange to contractual documentation in the published area. However, we often only see it kind of in existence as a singular flow for construction information. Whereas in reality, what we need to be focusing on is the fact that that flow exists at every stage. Now, okay, I put it in at 4 and 5, which you don't necessarily need to, but we need to understand that we should be signing off or at least getting kind of authority at each stage. So we're not going around and reworking elements that we could have perhaps had signed off previously. So we need to understand those exist at each stage through the project, and therefore we need something in place that will allow us to control those. And if I'm honest, folder-based kind of, your file server to try and manage that flow just is going to tie you up in problems down the line. So let's break this down into a bit more information, or a bit more detail, I should say. And let's look at how information flows across this. So this, as I say, is really digital engineering. It's about managing all the flow of information, and it's how you engineer the way you work. So I'm going to focus specifically on models as we move through this. So these are your kind of elements. This is your kind of setup to your CDE. You've got different roles and responsibilities. You've got different task teams. You've got a client or a client's representative, and you have tasks that each party will be responsible for. Now we begin with an information author in a singular task team. So let's say they're the architect. Admittedly, I couldn't get enough diagrams of models, but in principle, you begin with a singular model. This is level 2 BIM, not level 3, so it's federated. So we begin with a model in the work in progress environment with an information author in that team. I should state work in progress, not visible to anybody else but that task team. I then may have a second information author in that team who develops that model into something more advanced. I appreciate that's a pencil drawing, but let's imagine that it's a model produced there in whatever tool you choose. At the point that information then is okay to be shared, it doesn't have to be completed by any means, but it needs to be kind of check, review, and approved by a discipline lead, so an architect lead in this case, to say, okay, we are fine to share that with a mechanical engineer to begin creating the frame for the building itself. So the task team manager signs that off and we move the model into the shared area. Once it's within that shared area, it then does become visible to the other task teams, but still not visible to the client team at this point. So within the shared area there, the task team B, let's call them the structural engineer or civil engineer, they can take that model into their work in progress and then beginning work on their own model. So they produce now a structural model within their work in progress environment, and they may go through iterations of that as well. The same process then applies. A task team manager will look at that structural model, task team manager, discipline lead, so your civil or structural lead, and they will say, okay, yeah, we are fine to share that and move that into the shared area. And level 2 is about the federation of those models. So you need a means by which that those models are now going to become one. And it's also key that you archive, that you track that those models, where they came from and how it was federated together. So should you need to go back, you've got very quick auditability around everything that you need. So you've now got that information in the shared area, and we proceed with the same process to move into the client shared. So if you do want client comments, and I dispute a little bit the purpose of the client shared area, my query is, what if you want client comments that aren't contractual? So we tend to use the client shared area for that. Of course, you can also move it as the stopgap before you move to published. But let's focus on, we just want client comments now. An information manager will move that model across into the client shared area. They can then comment on it, and they might request an adjustment to some aspect of it for whatever reason. Let's say we want a pillar moved out of a certain area or a column moved out of a certain area for the purpose of, we want shop space there, let's say. So it goes back to the task team, they revise, and they then can return and share accordingly. Again, that archive is really, really key. At this point, we just bring in task team C. Now, they may only be doing a specialist part of the model, but the key point is, even if you're doing a specialist part, by the basis of level 2, we should really be looking at having them have their model federated in as well. The more we can get it focused upon modeling, the better, because the more information we can then federate together. Again, you'll note that throughout all of this, I don't refer to a specific model system. I don't refer to, you have to use Revit or you have to use Bentley or Vectorworks. And I want to stress that point, that from an EIR as a client, you shouldn't be defining specific softwares either. What you should be defining is a model. And then it's up to different providers what they need. And preferably what we should be working with, and we'll have to towards level 3, is working in IFC format, so industry foundation class, where it's open. So it is down to the task team to specify which tool best suits them. So in this case, I've got task team C, who may be using a different piece of modeling software. And what I can then do is, of course, move that into the shared area once it's been signed off, and we federate the whole procedure together into that singular model. So we've always got that single source of truth. We always have that one model that contains all of the information contributed by those different task teams. Now, at this point, obviously, let's just say I'm looking for sign off on this. I'm looking for authorization at whichever stage. Remember back to that where I dropped in the diagram at each stage of the process. This is key. I should be getting authorization. I should be getting this model published at each stage of the project. So at this point, I may produce my drawings. I still see too many clients doing 2D coordination and then having a model to do some 3D clash detection as well. We should be trying to pull it together. We should be trying to pull the sheets out from the completed federated model once all the clash detection, everything's been done. We shouldn't really, from level 2, be starting in a 2D environment. We should be starting 3D from the model, work the model up, federate, and then producing the sheets out. And then what we do, of course, is move that into the shared area and across to published, and it will be down to the client's representative to authorize that information to say, yes, contractually, this is what we asked for. They're not checking the technical information that's presented to them. That should have been done and will have to be audited that it has been done by the task team leads. What they are checking here is to say, okay, this is what we asked for. I asked for a hotel with X number of rooms. This is the floor space I asked for. It's that kind of information that they are looking for. And it's that kind of element you should be getting sign off for the clients to ensure you don't open yourselves up to rework when they change something that perhaps could have been captured far earlier in the process. So we then have information that's displayed into the published area and signed off by the client's representative, and that now represents a contractual delivery of information. The point you should be paid if you weren't paid prior to that, depending on your agreement to the client. But you have now delivered your information as part of that process, and that will of course have been tracked through the CDE and through the information delivery plan that we mentioned before. So that's the kind of my overview of how the CDE should operate. So we've kind of dealt with primary model information there primarily. We talked about kind of lead consultants focus on things. Okay, the third task team, we looked at secondary model information. But for me, secondary model information could be anything. And this is where you go to all sorts of kind of trade fairs and you see a huge amount of people walking around with AR and VR. And I think that stuff is great, but I think we need to focus on where the value is right now. So let's just talk about the BIM dimensions. So we started off with a point, 1D. I'm going to skip through the first two pretty quickly. We added a second point to create a line. We ended up with 2D. Okay, and then we added a depth to that. So that gave us a 3D. That gave us the model that we require. Now, digital engineering now is saying, okay, with that model, what's the next things that we can do? And okay, I'm going to talk about all the other elements in a second, but the next thing I can add is actually some time element. I can move into that fourth dimension of BIM. I can start planning, okay, if I deliver the model in this way, where are my clashes from a time perspective going to be? Where am I going to have cranes that need to do too many lifts on one day? So I can start tracking that fourth dimension. We obviously want to start costing it as well as a key part. We want to be able to track very quickly, if I do make this change, where's it going to impact and how much is that going to cost me? How much is my load going to change if I resize or remove that column or I need to cantilever that beam? So some cost element to the model is going to give me a lot more value as well. But I still have to start with the model. So I still need to work through these, which is the key point about why I've said you need to add 1, 2, 3, 4, 5, is because you have to work through it progressively. Then starting to move a little bit towards BIM level 3, and I want to make clear the difference between the BIM dimensions and the BIM levels. The BIM dimensions are about the amount of information within your model. Some may kind of disagree with exactly my wording there, but it's about the information in your model. The BIM levels are about the way you manage all the information that relates to it. So you can have a 5D model, a BIM 5D model that is BIM level 2 compliant. Now that will confuse some people, but you need to make the differentiation between those. So 6D, adding sustainability, adding even more information to my model. As I say, it starts to relate a little bit to BIM level 3, and certainly towards BIM level 3 is facilities management aspect there. And then we have a model with 7 dimensions in it. So generally in the industry, I kind of see a balance between 3 to 5 now, depending on the kind of clients we work with. Okay, maybe 2 to 5 is fair. And yeah, those are the BIM dimensions that we are looking at to move through. And of course, I've mentioned it, and everyone gets very excited at kind of all these events to talk about, oh, we've got, you know, a HoloLens now, or we're using blockchain, or we're a blockchain company and we're looking to do this, or we've got drones and exoskeletons. Okay, that's great, but we still need to focus on the core parts first. That these kind of solutions don't add lots of value to us at the moment, whereas having cost information against a model so I can identify how a change is going to impact my final cost because a client's making a change late and I want to correctly charge them for it, that's where it's really going to add value. These aspects, of course, they add value and they're nice to have on site, but are they really kind of going to change the way we're doing things? So this is just, again, it's an anecdote I use quite often, and I was heard at Digital Construction Week in the UK about a year ago, actually, by the head of Crossrail at the time. Unfortunately, obviously, Crossrail is slightly delayed now, so which is a little bit disappointing for the sake of my anecdote. But anyhow, there's 2 stations, particularly I want to focus on as part of Crossrail, so Liverpool Street and Tottenham Court Road. And for all intents and purposes, they were very similar stations in design, in the way, in the delivery, in the materials, in the passenger numbers that were to be transported through them. The primary difference was that one station could be built due to logistics and logistics only. One station could be built largely off-site, and one had to be built all on-site. It had to use information on-site and materials, and it had to be done in situ just for the logistical restrictions on that site. And you can quite clearly see the one that was built in situ on site was Tottenham Court Road. It took 67,000 hours to build. And okay, there was model information there, so don't think I'm saying that Tottenham Court Road was necessarily done badly. What I'm saying is, let's look at how Liverpool Street was done. It had a complex model. It had brilliant information in terms of how the actual station and the platforms were built. They had a fantastic system to drop in situ panels down and then ran them on rails to the correct point in the station to create a whole, or essentially off-site built. It was an IKEA model station, if you like, where it was all put together by just 7 people on site. And the difference between the time to complete those largely similar stations is absolutely phenomenal. And Liverpool Street could not have been achieved without digital engineering, without the correct management of information, without all of that model information being correctly delivered. So it's really key. And what I'm saying is, if possible, because obviously there are going to be constrained sites, but there's very few that are more constrained than Liverpool Street, if I'm honest. But if we can do this, then we should be looking to do it, because the savings could be enormous. So that's my kind of argument to that. And then the third part and the final part, kind of to this digital engineering aspect, is the asset model. At the moment, there doesn't appear to be too much focus on this, perhaps because it does simply fall at the end of projects. And with BIM, obviously the mandate in 2016, we're largely focusing on the start of projects right now. But as we are starting to see new projects, particularly kind of major projects within the UK that we can all relate to, a particular railway that is to be built in the next kind of 10-15 years, without mentioning specifically, they're looking for kind of digital twins of the information. They're looking to be able to have a piece of infrastructure built on site, but they're also looking to be able to have a digital version of that they can track and relate to it. So if an element of that infrastructure fails, then they can very quickly obtain all the information about it. They can obviously order spares, order maintenance, they can identify the maintenance record. It's about having that compared. And it's this part of the standard, it's more PAS 1192 part 3, which I'm not going to go into in too much detail beyond what I've kind of said, but it's about having that information and then managing that for maintenance purposes, but also to feed back in for the next project, to feed back into those EIRs and the lessons learned the next time around. And I think we'll see that becoming more and more apparent kind of going forwards. As evidence of this, again, looking outside the industry a little bit, Rolls-Royce. So Rolls-Royce now makes more money from guaranteeing the flight time of their engines and maintaining their engines than they do from building new ones. Wouldn't that be a brilliant concept to apply to a construction company, a company that has so much data and information about the projects that they've built, that they make more revenue now from managing those assets and providing that asset information to clients than actually building that client new assets? So something particular to think about as well. Okay, so everything I've done so far is things, I think, identifying the challenges of the industry, identifying how we can all make improvements, how we can actually start today and say, we can make these improvements. The disruption starts with the same theory, but then it advances on to say, okay, let's look at really different ways of doing things and how can we really do something completely different. And I think for large organizations, it's not easy to do this because it maybe needs to start on a small pilot project and there's obviously cost associated to it. But I think disruption is a really key point. Now, as I say, I start with generally improvements. This may be a disruptive approach, but I'm starting generally that this could be applied to any business. So this is a theory that I kind of developed again with kind of speaking with a client and understanding how they worked. I call them project time locks. So largely, my experience from in the industry is most organizations that work project to project on a singular project of X time frame, let's say 3 to 5 years, they will specify on that project they are going to use certain ways of working. They're going to use certain softwares. We're going to use Revit version 17. We're going to use these type of setting out equipment. And for the duration of that project, they're largely locked into using that amount of technology. That is the extent to which they can move. Okay, there may be some learning through the project, but they're so focused on delivering that project that technology is locked into that amount. And if you tie that back to that chart I showed right at the start, where there's a clear connection between the amount of technology used and the productivity of a worker, through that project duration, you are largely locked into that amount of productivity. At the end of that project, we then want to learn the new technologies that have been released during that duration, and we want to start project 2. So we learn, but the problem with learning is, of course, there's only so much you can learn in a short space of time. So I've defined it the learning curve limit. You can only learn so much between project 1 and project 2. And what that means is on project 2, okay, you have new versions of the software you're using perhaps, but you are still locked into how much you can really get the value out. And so this continues essentially to project 3, and you will forever be kind of chasing the technology. And I think fundamentally, this is the reason the construction industry largely has very low kind of technological advances when you compare it to something like manufacturing. Manufacturing, they learned much more quickly. My theory to how this could be applied to the construction industry is to change the way the project teams work. And I'm already seeing this happening in large kind of clients that we work with that now have centralized digital teams. And what those central digital teams are able to do is to basically say, okay, at day 1, at the start of project 1, at the point of setting up, we are going to continually learn the new technologies that exist. We are going to go out, we're going to look at the best softwares, we're going to look at the best CDs, we're going to look at the best ways of working, we're going to push technology providers to do better, and we will continually learn these technologies. And what we will then do is we will advise and we will influence the projects as they go, but they're still kind of largely locked into the technologies they use. But between projects, we can now harness so much more knowledge that what you end up with is each project now using a much more advanced set of technology than they would otherwise have been capable of. And tying it back to that original diagram and that original chart I showed you, if we are using more technology, then the evidence suggests we will be more productive, and that therefore we will be saving cost or increasing our margins. So we end up with a maximum technology use much increased to where we were previously. So I'm going to finish with a few companies that aren't in the AEC industry. For me, if you look at what a comparable company in the AEC industry is doing, and you say, oh, okay, they're doing something very well, we're going to do something similar to that. That's transitional. That's just competition. For me, if you want to disrupt something, you have to look completely outside it and say, we're going to do something completely different. And I've kind of picked a range of companies here that I think have done that, and they've looked completely outside and gone, we're going to completely disrupt this. So let's just go briefly through those. So Uber, they came into essentially, transporting people from A to B and the taxi business, and they said, okay, we're going to revolutionize this by using technology. We're going to use apps, and we're going to get people from A to B, which is fantastic. It's brilliant. It was the fastest increase in size company about 2 years ago. Now, my kind of question here is, why can we not apply that same principle to the managing of logistics on a construction site? We need to know where all things are arriving, what time they're arriving, the same kind of things that Uber does. It tells you when you're going to get from A to B, what time you leave, what time you arrive, what the traffic is. And yet, as being a site engineer on site, I know trying to manage the concrete delivery on site was a nightmare, because one minute I'd have no concrete wagons, the next minute I'd have 5 queued up out the gate, purely because there was no means for me to manage the delivery of that information. Nest, so they are basically to manage, they do smart thermostats, but largely smart home control, basically. So it's about managing information and data and producing more data about your home particularly. And again, I kind of maybe slightly loosely on this one, but why don't we add some more data capturing tools to construction projects so we can start harnessing more information? Amazon Alexa. Now, the particular point with Alexa is not the voice activation, it's the ordering that I find particularly interesting. So it's the ability of Amazon and Alexa now to say, okay, you've ordered this on this date, and then you ordered it another month later and a month later. So my prediction now is you're going to need one in a month's time, and it starts to predictively order the things that you need. Obviously, it's great for Amazon, it causes you to buy more things. But let's also apply that to the construction industry and say, okay, why can't we look, or with perhaps as part of a connected system, that if, let's say, a light goes out or a light blows, that the sensor will pick that up and it will pre-order it for me. I look forward to the day from an FM perspective when I only know a light bulb has gone out because a new one arrives in the post and says this is a new light bulb for this one that's gone out on the project. So starting to look at predictive ordering. Again, they've taken something outside the industry and applied it there to the shopping environment. Airbnb, biggest hotelier in the world, yet they own no properties. They're now a huge threat, and we're seeing, okay, governments cracking down, as typically they will do in terms of technology, really disrupting things. But they focused on kind of service fees, and they focused on a different way of generating revenue opposed to actually having to own the property. So again, an interesting application. It kind of ties to that Rolls-Royce one I mentioned. Could we make more revenue? Could we generate more revenue as an AEC industry by delivering and managing the assets better for our clients? Tesla's an interesting one. Obviously, they're a bit up and down at the moment, opposed to when I originally wrote this. But I think it goes to show that Elon Musk is maybe a bit of a chaotic but quite brilliant thinker about the way they do things. The thing with Tesla is not the electric cars. The electric cars is going to go that way anyway, regardless of whether they came to disrupt it or not. What I find interesting about Tesla is the technology they have in the cars, recording huge amounts of data that are better allowing them than anybody else to go out and deliver self-driving cars, which is really the game changer. The first to come out with a really successful self-driving car is going to be the one that changes the game. And what Tesla are doing are capturing data from all the cars that are on the road at the moment to help feed into those self-driving cars. Just to give you an idea of the data required by a self-driving car, the information it processes, the current estimates are around 100 gigabytes a second. So a self-driving car is using and consuming that much data that quickly. That's how much information we are going to need to get self-driving cars. And then Citymapper, this is my favorite one and a brilliant one. And I actually I did put it on my LinkedIn yesterday about it because it's the first time I've actually used the service, or the Smart Ride service. So what they did is they started off by capturing data and using data of people going from A to B in cities, let's say London. So I want to go from here to West London, for example, and I needed to know the fastest route to do that. So I would use Citymapper or Google Maps. What Citymapper did brilliantly was to start to track the time between destinations. So let's say as the crow flies, I was traveling 10 kilometers and it was taking me half an hour. But when I was going to another destination of also 10 kilometers, it was taking me 45 minutes. And what they were able to identify capturing that data was the black spots in the network, was to say, okay, this is where the transport network is failing because there's not a route here. And they then introduced a service, which I used, as I said, for the first time yesterday, called Smart Rides, to say, well, this is a gap here. So we're going to generate revenue by introducing a service that runs exactly on this route where there's a weakness. It's brilliant the way they use that data. So for me, going through all of those examples there, the one word, hopefully, you heard me say on a regular basis was the word data. Data is the center of all of the disruptions we are seeing. The Economist did an article a couple of years ago that data is the new oil. Data is the value that a company has now. So if you look at oil and how that has impacted, it's allowed rapid industrial growth, it allowed transportation for everybody. It was the base of a lot of economies. If you look at data now, we look at the biggest companies in the world, your Googles, your Facebook, okay, Apple to some extent, but they are using the data more and more to add more value for you. Again, it's being restricted and guided by governments, and that's correct. You know, you look at GDPR across Europe, but data is still the value that a company has. And it's data that's going to allow us to do things like have self-driving cars, have intelligence and artificial intelligence and machine learning. So it's all about how can I now make the most of that opportunity with my data. The problem I've got with my data, and it being quite singular, and I'm keeping my data to myself, is that it's siloed. And if it's siloed and I only have my data, then there's a limit to what I'm capable of doing with it because there's only a certain amount of it. You know, for example, I couldn't go out by myself and build a self-driving car. So it's looking at, well, actually, if we have that data and we share it with other parties, and this comes back to the core of BIM level 2 and certainly BIM level 3, am I giving away my competitive edge? Because now I'm sharing everything that I'm doing with my competitors to some extent. So my argument is, well, if we have more data, okay, I've still depicted a silo here. I still depicted one place that data is being captured. I've still got people pushing in their models to a central CDE to be a single source of truth. But now I've got so much more data. my competitive edge isn't lost because I'm adding that data there. My competitive edge is how I use that data. It's how I use that data to my benefit. So if we've got lots of people contributing data into one place, my competitive edge is to say, okay, if I process the data, I might do it in this way, or I might do something better. And then you're obviously going to get the real leaders in the industry who say, actually, for my data, I can really make a difference, and I'm going to do something much more advanced. But it's using the same data set. So the key is, it's not just about capturing the data and delivering it, it's about how you use it. So I'm just going to finish. There's two sides to finish here. So again, looking outside the industry to improve the way we do things. So this is a company many in London, or certainly in the UK probably now will be familiar with. It was the Challenger company. They came in and they completely disrupted the banking game. They impacted it so much, a lot of the banks started investing quite heavily in their own apps and the way that they were managing the digital interaction with clients. They really got a lot of the big banks running kind of backwards. And so this is Monzo. So they came in with a completely new approach to the banking world. They've recently been described as a unicorn company, which is a company, a startup that is valued at over $1 billion. They recently hit 1 million current accounts. They're responsible, I think it's for around 20% of new bank accounts that are created in the UK. And they did that by a disruptive approach, a completely different way of doing things. They had an open approach to the way that they developed the information. They had an open forum for what features to be developed. That was open to anybody. Any competing bank could have gone and looked at that and said, okay, well, that's what Monzo doing. We're going to do the same. But what they were brilliant at was doing it in a way that was far better than what everyone else was doing, which is why they've jumped ahead of not just the other challenger banks. They've jumped ahead in that kind of field as many of the big banks with far much more value behind them and capital behind them. So my question is, how long before we see a challenger construction company? Because for me, the construction industry is pretty ripe for the taking in terms of an industry that is behind on technology, underinvested in technology, and really could have someone come in and say, we're going to do things differently. And they would look to do the same sort of things. They would look to be disruptive. They would have a kind of revolutionary way of doing things. And there's actually a company that have started doing similar. It's not exactly on the money, but in Toronto, a company called Sidewalk Labs are redesigning Toronto waterfront. They are creating a smart city from scratch. They are using completely new construction techniques. And perhaps almost worryingly for the construction industry, they were recently acquired by Alphabet, which is the holding company for Google. So this isn't a type of company that's all of a sudden going to run out of money. This is a type of company that could really change the way the industry is working. And as I say, how long before they impact or have a wider impact across the construction market globally? So that brings the end to my presentation on digital engineering. We've got kind of 5-ish minutes left for some questions, which I'll have a glance over now. But if I just hand back to Annie for a couple of closing comments and questions.
Thank you, Rob. Now it's time for the Q&A portion. So again, if you have any questions, please feel free to type them into your questions tab. So let's just take a look. Okay. All right. So Rob, hold on. Let me see. I have a question right now. First question. As an engineer within my business, can I cause a change in the way that we work, even though I am not in a senior role?
Okay, so this is also a thing as well. So I appreciate, we're not going to have all heads of businesses joining to listen to me talk about digital engineering. So it's the impact that you as an individual can have. And I think the primary thing is, let's look at how we could improve the way that you work, and let's look at how we could improve the way that your team works. So going back to that marginal gains as well, it doesn't have to be the whole business change their way they're working. But if you can prove within your team that doing something as an improvement is beneficial to your business, then my hope would be that would impact a wider audience within your business, and that's how you start to progress it. So even if you're kind of lower down in an organization, not necessarily in a decision-making role, you can still have an impact on what you're doing by suggesting good ideas and suggesting improved ways of working.
Okay, great. Thank you. Question number 2. What types of software are in place to support this type of digital engineering?
Okay, so from a software perspective, there's a whole kind of range of things. So you've got obviously your modeling tools, and I'll be honest, I don't come from that consultant engineering background, so different modeling tools will have their different values. I think the one key thing is we need to focus on an open, what we term open BIM. We need to ensure that whichever software is chosen is kind of delivering models in an open format. I think from the management of information side, you do need a CDE in there. However large or small your project is, you need a CDE, and you need kind of, to be honest, an organization like a site to deliver that central point for the flow of information, models, documents, file. It doesn't matter, but you need a center point for that flow of information. So that's where something like a site would sit in place to do that.
Great, thank you, Rob. Okay, let's see. Another question, what countries are the most advanced in terms of digital engineering? Would you consider the UK to be behind?
Okay, so that's an interesting one. To be honest with you, I would consider the UK to be one of the more advanced in this. I travel around a fair amount across different regions as part of my kind of role, and yeah, I would say the UK is fairly advanced in doing this because of the mandate and because of the standards. I think countries are quickly looking at that and then either having their own approaches or rapidly catching up. The US has quite a different approach to things, where they tend to approach things in a more disruptive way from the get-go, whereas the UK is more focused on working to a standard. So I think from a standardized industry perspective, digital engineering is done very well in the UK, but I think you're going to see more, so certainly with the ISO, other countries really making strides over the next few years.
Great, okay, we have time for one last question. Who do you see making strides in the industry currently?
So yeah, so it kind of ties to those countries. So it's surprising, particularly some large organizations. The centralized digital team for me is a really key part of that. So you will see some big contractors, for example, the likes of Langer Rourke, will now have centralized digital teams to deliver this information to their site and to their engineers. And I saw on site recently something I never thought I'd see, which was a steel fixer stood with an iPad and a 3D model of the cage reinforcement that was building up in front of his eyes on the iPad so that he could better inform his team how to do that on site. And that was something I didn't think I would see. But I think some of those large organizations are really investing quite heavily and quite quickly into this now, because once the demand for it comes from a low level, then it needs to be prepared and it needs to be available from the top levels within a business.
Okay, great. Thank you. Thanks, Rob. That was a great presentation. That's all we have for today. Thank you, everyone, for your time and interest. I know there's a lot of you who are asking for the slides or the presentation after, so we will be sending the attendees a recorded version afterwards. And if you have any further questions regarding this webinar, you can email me at alee@asite.com. That's alee@asite.com. You can also keep in touch and stay up to date with our upcoming events by connecting with us on our Twitter account, and that's at asite. Again, that's at ASITE. So thank you very much, everyone, and we hope you enjoyed the webinar. Take care.